Hello again. Today evening we will be speaking about next topic. We will be speaking about excited vibrations with taking into account damping. It will be about damped excited vibration, and like last time, it will be about single degree of freedom systems. And in our previous movies, we were considering such a case. We had a damped harmonic oscillator with the mass m, stiffness k, and the damping coefficient c, and there was the excitation F0. Last time, when we were speaking about in previous material about the system without damping, we derived the equation of motions, and approximately we remember that the methodology was as follows. There was something about the Lagrangian of the system, and we stated that after necessary derivation, you can check it on our previous videos, that the equation of motion of such a system will be as follows. There will be mx double prime plus kx equals f0 times sine, let's say, omega t. Oh, I forgot about excitation function. If we assumed that the coordinate frame will have the same facing as our force. And it was when the c was 0. If we want to take into account c, we have to include also the dissipative potential of our system. And we stated that it will be 1 over 2 cx dot square. You can check it in the video about damped free vibrations. And the contribution of that part, it was such a thing, the cx dot, because that thing is a partial derivative of d respected with the general velocity with minus. And if we transform that equation, rearrange that thing, we are getting such an equation, which is the governing equation of damped excited vibrations. Okay, here we have such a thing. We remember that for solving that problem, we have to make the factor of the highest derivative 3. It means we have to divide it by mass, the whole equation, and here we have following formula: k over mx equals f0 over m times sine omega t. We have such an element, and using the same substitution like last time, we are getting such a thing. First thing, we introduce the 2h as a c over m, and the k and the omega 0 square equals k over m. What we are getting as a result? It's such a thing. The x double dot plus 2hx dot plus omega 0 square x equals f0 over m times sine omega t, which sometimes is called a small f0. Depends on the case in the literature. Okay, and here we have our governing equation in the form of the acceleration, and we remember that if you want to find the x, solution, it will be the combination, the sum, the general solution of that entire equation. It's a solution of the homogeneous part, general solution of the homogeneous part of our equation, plus one particular solution of our problem. The particular solution of non-homogeneous equation. And if we are talking about that part, it's easy to solve, and last time we stated that it will be approximately exponent of minus ht times c1 sine omega ht plus c2 cosine omega h t. You can check it in our previous video about damped free vibration, and if we are talking about the particular solution, that is the question. Now it means that now we will be speaking how to find that thing, because it is the problem how to find solution under such an excitation. And generally we will be basing on the method of prediction, and like last time, like in the case of undamped excited vibration, we will predict the solution. Okay, and from the theory of the differential equations, we know that if we have the right hand side as a sine and a cosine process, we should predict the solution as a linear combination and the sine and cosine with the same frequency. I mean, in our case, it will be some constant, let's say E1 times sine omega t, the same omega as frequency of the excitation, plus, let's say, E2 times cosine omega t. Here we have such a thing. Maybe I will make my E a little bit better. Okay, and if we know, I mean, if we are assuming that it is a solution of our problem, it means that it has to fulfill our governing equation. It means that if I put it here, the left-hand side has to be exactly the same as the right-hand side. Okay, what do we need for that thing? We need first and second derivative, because in the moment we have to put it, we have to everything put inside our governing equation. Okay, the first derivative of our predicted solution, it will be omega times E1 of course cosine omega t. I wanted to be quicker than I can, and minus, because the derivative of the cosine is minus sine of the omega A2 sine omega t. What next? Next it will be second derivative, I mean the derivative of the first derivative, and we see that it will be minus omega square E1 times sine omega t minus omega square E2 times cosine omega t as a derivative of the sine. Okay, and now we are able to put everything together, and as a left-hand side of our governing equation, we have such a thing. I mean, it's a last component, and we will have to add the component connected with the damping. I mean, that thing, it will be omega E1 cosine omega t minus omega E2 sine omega t, and plus element connected with the stiffness, I mean with the displacement, and it will be of course E1 sine omega t plus E2 cosine omega t. Okay, and it will be equals to our right hand side in the form of the amplitude and sine function. Okay, it means that here we have a small f0 times sine omega t. And now we have to rearrange our equation. I will try to find the similar terms, I mean term with the sine, another term with the sine, and the same situation is here, and the terms connected with the cosine, of course, here, here, and here. And as a solution, I mean, as a rearranged equation, we have such a thing. I mean, here we have omega 0 square minus omega, capital Omega square times E1 minus, as a contribution of that part, minus 2h omega E2, and it will be sine component, sine omega t, plus almost the same thing. I mean, here we have the place for the cosine omega t, and it will be given by that thing. I mean, from the first element, here we have 2h omega a 1, and from that part and that part, I mean from the black one, we have omega 0 square minus omega square times E2, and it will be exactly equal to F0 sine omega t. And because it's a identity, we have to compare left hand side and right hand side, and we see that on the right hand side we have the left hand side we have the sine and cosine component. On the right hand side we have exactly the same, but the cosine is not given in the exact form. That is why I will add that thing in the form of 0, I mean 0 cosine omega t. And now we see that if we want to ensure that the left hand side will be exactly equal to the right hand side for every single value of time t, we have to compare that component with that component and that component with that component, because we can't assume that for any value of sine omega t and cosine omega t we will find the solution. It means if we want to satisfy the identity equation, we have to compare the appropriate coefficient. Okay, I will try to denote that thing in that way to show you what is the corresponding element, and the same if we're talking about that thing. Okay, and now we are able to rewrite our case. It means here we have omega 0 square minus omega square times E1 minus 2h omega E2 equals F0, and from the other hand here we have, the parentheses won't be necessary, 2h E1 plus omega 0 square minus omega capital omega square times E2 equals 0. And it is the system, linear system of equation which give us unknown parameters E1, E2. How to solve it? We can use, for example, the method of the matrices, I mean the Kramer method, and we know that the solution, I mean the E1 for that case and the E2, it will be the determinant of the matrix connected with the first element, let's say A, E1, over the determinant of the main matrix of the system, and the same situation it will be for A, E2 over determinant of the main matrix of the system. How to find the main matrix of the system? It will be the matrix of the coefficients, matrix of the factors connected with the particular elements. I mean, it will be the first element, second element, third element, and the fourth element. Okay? I mean, we see that it creates somehow the square matrix, and using that values, we have the appropriate coefficients in such form. Okay? And it will be the main matrix. The next part, it will be for E1, and how to do that? We have to remove first column and put the vector of the three terms. I mean, it will be F0, 0 minus, that part will be exactly the same in the case of the main matrix. And if you are talking about the matrix for the E2, it will be, we have to rewrite the first column, I mean 2h omega, and that thing, it will be F0 times 0. Okay, let's start with the computations. We have to compute the main determinant of the main matrix, determinant A, and it will be, as we see, that value squared minus that value squared, but here we have the minus again. I mean, the whole result will be positive number. Okay, it means here we have omega 0 square minus omega square over, squared, minus, I mean plus, due to that thing, it is 4h square omega square, okay, due to that product. Here we have the determinant of the main matrix. For the other matrix, we have such a thing. That thing is easier because we have some zeros, I mean it will be that product of that element from the diagonal, and that component will be 0. That thing will be 0. I mean, again, the determinant of that thing, it will be product of that thing minus product of that elements which are here and here, okay? And it will be 0 as a value. I mean, here we have f0 times omega 0 square minus capital omega square. And if we are talking about the last determinant, it's such a thing. It means here we have 0 as a contribution of that element and the negative value due to that thing, because as we see, it will be minus of that product, minus f0 times 2h omega. And now we are able to find the solutions, and it will be, in that case, it will be f0 omega 0 square minus omega square over that whole thing. I will put it in the moment. And the second thing, it will be minus f0 to h omega, and I have to divide it by that thing. It will be omega 0 square minus omega square squared plus 4h square omega square, and the same will be here, omega 0 square minus omega square squared plus 4h square omega square. And the final form of the solution, I mean the particular solution, predicted solution, it will be linear combination of that element. Okay, it means that it will be 1 over, because here we have the common factor, squared plus 4h square omega square times omega 0 square minus omega square times sine omega t plus, minus as a contribution of that minus, okay, or maybe I want to improve myself, minus f0 to h omega as a factor of the cosine omega t. Okay, let's close the parentheses, and now everything is fine. As you see, it isn't especially complicated. It takes some time because there is a lot of the computations, but some process is easy, and it's exactly the same like in the case of the undamped excited vibrations. Thank you for your attention. See you on lectures.